All right, in our second video for section 10.1, we're going to talk about expressions in the form of the square root of a squared. You notice that we have a square root, but we also have a quantity squared underneath. Let's see what happens. In example number 4, it asks us to evaluate the square root of a squared for each of the following, which means, for example, in part A, if a was 5 and I substituted in a 5 and simplified, what would happen? Well, let's try it. If I take the square root of a squared, but instead of a, substitute in a 5, and then I go to simplify, well, what's 5 squared? 25, right? And what's the square root of 25? What number multiplied twice gives me 25? Don't you end up getting 5? So we actually ended up getting back where we started, right? Well, look at 0. What is the square root of 0 squared? Well, if I substitute in a 0, 0 squared, 0 times 0 is 0. And what's the square root of 0? What times what? Gives me 0. Well, 0, right? And so again, I ended back where I started. That's kind of cool. So it looks like the square and the square root kind of cancel each other out, don't they? If you square something, you're multiplying it by itself. And then when you square a root, you're trying to figure out what number multiplied by itself gets you back that number. So you're kind of going 2 steps forward to just go 2 steps back. It looks like we could just say that our final answer is just whatever we started off with, right? Well, let's try -5. If I substitute a -5, let's see if this is any different than the +5. If I substitute in a -5 and I do -5 squared, remember that's a -5 times a -5. That gives me +25, doesn't it? And now what's the square root of 25? Remember, we're talking about just the principal root. So what positive number multiplied twice gives me 25? Did you say 5? So did we just end up where we started with? Oh, wait, we didn't, did we? So what's different on this one? Or what general rule could I say works all the time if I take the square root of a squared number? Well, it looks like 5 still ended up as 5, and 0 still ended up as 0, but -5 ended up at +5. So really, can't I, if I'm square rooting a squared number, take the absolute value of that number inside? The absolute value in the first one, if my 5's went away, the absolute value of 5 is 5, isn't it? And the absolute value of 0 is 0, isn't it? And the absolute value of -5 is +5. So that works, doesn't it? If I square root a squared number, then I can say that my answer is really just the absolute value of that number that was inside. What should happen is anytime we're simplifying these things and we have a square root, we need to be careful that our answer is still equivalent to our original version. Meaning, I should be able to plug in any value and the left side should still equal the right side. For example, if I were to plug in, for example, an x squared, and I would say, what quantity multiplied by itself gives me x squared? And I said the answer is just x. I should be able to plug in any quantity, any amount in for x, and the left side should still equal the right side. So if I plugged in a -1 to both sides, that statement should still be true. The left side should still equal the right side. Well, let's look. If you look at the left side, -1 squared is +1, isn't it? And then if I take +1 and I square root it, what's the square root of +1? 1. But on the right side, if I substituted in a -1, well, then the right side equals -1, and +1 does not equal -1. So then what would I have to do to this right side in order to make the equation still true? Well, if you notice, if I slap some absolute values on here, what's the absolute value of -1? +1, and then my statement is true. So anytime I square root a quantity squared, I need to make sure that I add absolute values to my answer so I can make sure that my left side equals my right side, that my equation is still true. Let's do a few more and add some more variables in there. In example number 5, it asks us to simplify the square root of 36t squared. Now, you can think about these as separate quantities if you'd like to. You can think about 36, the square root of 36, and t squared. Now, what number multiplied by itself gives us 36? Did you say 6? Okay, so now let's think about t squared. What quantity multiplied by itself gets us t squared? Well, what if I did t times t? Doesn't that give me t squared? So I can say that the square root of 36t squared is really 6t. Now we've got to be careful. We need to make sure that no matter what we substitute in for t, the left side equals our right side. So let's pick a number. And the easiest number to check is always -1. So that's what I'm going to do. Without the absolute values, would this be a true statement? Could your answer just be 6t all by itself? Well, if I plug in a -1 and I simplify both sides, on my right side, 6 times -1 is -6. On my left side, -1 squared is 1. 1 times 36 is 36. And what's the square root of 36? 6, right? And does 6 equal -6? No. So I need to do something to my answer to make sure that it actually is the correct answer and works for any value of t. What would I have to do? Well, if I put some absolute values on it, would that make the statement now true? Well, 6 equals, the absolute value of -6 is 6, so now it works, and now my answer is true. The square root of 36t squared is really the absolute value of 6t, not just 6t, but absolute value of 6t. Let's do some more. Look at b. I have the square root of the quantity x plus 1 squared. So that really means inside that I have an x plus 1 times another x plus 1, right? So isn't that its square root? So what quantity multiplies twice to give me x plus 1 squared? Well, that's just my x plus 1 times another x plus 1. Okay, but without absolute values, is that statement true? Well, let's check it. Again, the easiest number for me to plug in is a -1. We always want to test negatives to see if it works. Or maybe in this case, a -2, because we want to be able to square root it. So let's see. If I chose -1, you notice that I would get 0, and then it's kind of hard to tell because 0 is neither positive nor negative. So I chose the next easiest number here, and I chose -2. I substituted a -2 into both sides, and you can even put absolute values on there if you want to see if it would work or not. When I substituted in a -2 plus 1 is -1. -1 squared is +1 on the left side. On the right side, -2 plus 1 is -1. And so now I have this situation where I need to figure out if I need absolute values or not. Well, I know on the left side that the square root of 1 is 1. And over on this side, if I didn't have the absolute values, I would have a -1, which isn't true. Soon as I slap on those absolute values, the absolute value of 1 is 1, and then I know that the statement is true. So my answer definitely needs those absolute values. All right, let's look at C. C is a little bit different. I have an x squared minus 8x plus 16. I have 3 separate terms in there. This one's a little bit harder because I want to figure out what quantity multiplies twice to get me this expression underneath. It's a little bit hard to figure out because I have 3 terms. Unless, what do you notice? Well, maybe I can factor what's underneath and see what it multiplies into. Okay, so let's see. It looks like this is a basic factor, numbers that multiply to 16 that add to -8. So I ended up getting x minus 4 and x minus 4. And you notice that it's the same exact quantity twice. So instead of writing it twice, could I really say that I have an x minus 4 squared? And so now it actually looks like the form that we've been talking about, the square root of something squared, right? And we should be able to say that the square and the square root kind of reduce each other out. You're squaring to then square root. And so I end up with an x minus 4. But do I need absolute values? Because it's that quantity where we have something squared and we're square rooting, we need those absolute values so that the left side equals the right side. Maybe try some numbers and see if it works. Try -1. With or without those absolute values, would it work? It looks like on this one, we need those absolute values because 5 wouldn't be the same as -5. So again, anytime we have the square of a square root, we need to make sure we add those absolute values. Okay, look at D and E. These are a little bit different because we don't just have squares anymore. We have the square root of t to the 6th power. Okay, I want you to think about this one. I want you to think about what quantity can I multiply by itself to give me t to the 6th? Well, t times t is t squared. T squared times t squared is t to the 4th. Not quite. But what about t cubed times t cubed? Doesn't that give me t to the 6th? So I can say The square root of t to the 6th is really t cubed. But now, if I were to substitute in a number, any negative number, would that statement be true? Well, let's try -1. If I plug in -1 and raise it to the 6th power and then square root it, is that the same thing as -1 raised to the 3rd power? Let's see. -1 to the 6th power, negative times negative times negative times negative times negative times negative. An even number of negatives should give me a positive 1, right? The square root of 1 is 1. Let's see what's happening on the right side. If I take -1 and cube it, negative times negative times negative, that gives me a -1 on that side, doesn't it? So in order to make this answer true and valid for all t's, don't I need those absolute values on that right side? That's really important. Okay, I want to look at E with you, and then we're going to go back and look to see if there's a strategy that we can think of anytime we see these type of problems. Look at E. E says we have the square root of a to the 8th. I want you to think of what two quantities multiply by itself to give me a to the 8th. How about a to the 4th times a to the 4th? So I can say that the square root of a to the 8th is really a to the 4th. Now, do we need absolute values? Let's look. Let's try a number. Again, maybe -1 might be the easiest. And let's substitute it in to both sides to see if it's still true. -1 to the 8th power, a negative number to an even power, an even amount of negatives, is going to give me a positive 1. The square root of positive 1 is 1 on that left side. Let's see what's happening on the right side. If I take -1 and raise it to the 4th power, that's a negative number raised to an even number. If I have 4 negative numbers, doesn't that also give me a positive 1? And I didn't need absolute values on this one. I tricked you. So there is no absolute value needed on this one, and I can say that my answer is actually just a to the 4th, no absolute value required. So what's the difference? And how the heck are we supposed to know when we need them and when we don't need them? Well, here's kind of a trick. Anytime I'm doing a square root or an even root, I need to be worried about negative numbers because remember, we're not allowed to have negative numbers underneath. When my answer has an odd exponent, an odd exponent, an odd exponent, an odd exponent, then I need absolute values because an odd exponent could produce a negative number, but an even underneath, we need to make sure that it is positive. But if I have an even, and I'm worried about negatives, but my exponent to my answer is also even, well, if I have an even, I need positive, and if I have an even in my answer, it's going to end up being positive, so then I should be okay. So if I have an even root, an even index, a square root, I need to be worried. If my answer has an odd exponent, then I need absolute values. If my answer has an even exponent, even and even, then we're good and we don't need them. Okay, make sure you practice that idea. The only way that that's going to make more and more and more sense is to make sure that you practice. Let's do a few quick ones in example number 6 in this video, and then we'll move on to graphing these different types of problems. Example number 6 also asks us to simplify. In this one, though, it says, assume that the expressions being squared are non-negative. So we don't have to worry about negatives, which means we don't have to worry about absolute values. So let's just try to simplify. If you look at A, we want to do the square root of y squared. So what times what gives me y squared? Well, did you say y? And on this one, we don't have to worry. But if we had to worry, if that wasn't in the directions, then remember, we have an even index, so we're worried, and our answer has an odd exponent, so I know that if we were worried, we would have needed those absolute values. All right, what about B? B says the square root of a to the 10th. Okay, what quantity times what quantity gives me a to the 10th? Has to be the same thing multiplied by itself to give me a to the 10th. Did you say a to the 5th? Now you noticed I have an even and an odd, so if I were worried, I would have needed those absolute values. But because the directions say we didn't have to worry, we could just say a to the 5th would be our final answer. What about C? C has a trinomial inside. And it's kind of hard to tell which numbers have to multiply to give me that trinomial if I don't know what the factors are. So let's actually try to factor it. Maybe pause the video. This one looks like a bottoms up factoring. Do you remember that? See if you can remember your steps for bottoms up and factor the 9x squared minus 6x plus 1 for me. All right, when I factored it, I ended up actually factoring into a perfect square of a 3x minus 1 and then another 3x minus 1, two of them. So since there's two underneath, then I know that 3x minus 1 times another 3x minus 1 is my 9x squared minus 6x plus 1. And so if I'm looking for the square root, I can say that the square root is really just the 3x minus 1. I'm not worried about negatives on this one, but if I were, I noticed that I had an even index but an odd exponent. So if I were worried, I would have needed those absolute values. So make sure you're paying attention to the directions. If it doesn't say anything about not worrying, then you need to be careful with those absolute values. If it says don't worry about it, well, then you can just simply simplify.